I'm going to go over this week's procedure for the distillation lab. We will be using our macro scale distillation glassware, and be sure to get your TA or me to approve your distillation build prior to turning on your heat and actually heating your solution. We will be sharing data at your lab benches this week, but remember, you must be capable of building and explaining both distillation techniques in your technique check in the upcoming weeks. You will be building your distillation apparatus using the toolboxes that you checked out on the first week of lab or in the first week of lab. For those of you in the large organic lab, that means your toolbox kits are underneath the bench. In the smaller quant lab, PChem lab, then if you recall, your toolboxes got put on a side bench in that lab. Be sure to use the kit that you checked out on the first day of lab. You're responsible for the glassware in that. So to recap, we are doing distillations. The two different ways that you can do distillations are simple and fractional. And Travis has recorded a video demonstrating the differences between those two. And also be sure to refer to the macro scale part of your lab book when needed. Macro scale requires 25 milliliters of each of our two solute solvents that we're using this week, which are cyclohexane and toluene. Remember, after you've put together your build and gotten the go-ahead from your TA or from me, your professor, you should turn on the water for your condenser column. We want to make sure that the water hoses are connected correctly when we're doing the check, but then you'll want to turn on that water so that your vapors will eventually be able to condense and be collected. We will be heating with sand baths. We will not be using Bunsen burners. And you can control the heat of the sand bath so that the distillate rate should not be faster than 1 drop per second. Basically, you should not be observing more than 1 drop of liquid or distillate, as we would call it in this lab, coming off and being collected in your graduated cylinder per second. You're going to want to record the temperature at the first drop that you see, and you'll need to take temperature recordings after every 5 milliliters of distillate. We will be creating the simple versus fractional graph that you saw an example of in the pre-lab. So make sure to record this temperature very diligently. You will want to change out your receiver after approximately 25 milliliters of distillate has come off, or when you notice a drop in temperature, whichever one comes first. Obviously, if you notice a drop in temperature, you'll probably want to bump up the heat on your sand bath just a little bit to get your second material to distill off. Be sure once you are done, you do not let your pot or your round bottom, as it's also called, distill to dryness. Once you are done, you should have maybe 3 to 5 milliliters left in the round bottom. You're going to want to turn off the heater or the heat source, our sand baths in this case, and lower the heat source from the round bottom. Your build should be done in such a way so that you can remove the heat source without disturbing the glassware setup. Once your round bottom cools, that's when it's safe to turn off the water running through the condenser, because you shouldn't have any more vapors that need to be condensed so they don't come out into the laboratory. You will want to observe and record the volume of each of your 2 fractions that you've collected and measure the refractive index of both fractions. For reference on refractive index measuring as it applies to distillations, your lab book, for whatever reason, didn't put this into the macro scale versions, but it did in one of the micro scale versions. So please read page 76 in your lab book if you have questions about the refractive index portion. I will also post a video on measuring refractive index. This is one of those small micro scale techniques that you can read more about in the second lab that's in your lab book. That will be one of our makeup labs should somebody miss lab due to COVID. In terms of potential errors for this week's lab, one of the major errors that will significantly affect your lab report is gaps in your distillation glassware setup. Traditionally, these gaps are at the joints. We're using glass ground joints, so a lot of times it's hard to tell, especially if you're not used to the glassware, whether your two pieces of glassware are sitting down fully in one another, or if perhaps there's a small, maybe centimeter gap. Obviously, if there's a gap, vapors can escape and you will not collect the volumes that you were supposed to. Other things to be mindful of is the clamping of your glassware, as I said earlier, as well as your water flow and that the water's turned on at all. The other big error and also time suck for this lab is a poor heat transfer rate. Sand will transfer heat. It does it fairly slowly. So get your glass stirring rods out. Do not use a metal spatula, but get your glass stirring rods out and stir your sand. Don't stir it so violently that you have a lot of sand to clean up at the end of the day, but be sure to stir your sand so that the hot sand gets moved from the bottom up towards the glassware. Honestly, you'll be surprised at what stirring your sand will do in terms of giving you a more even heat transfer rate and also speeding up your distillation. Good luck.